At number 6 on graphing common functions 2, and we are going to talk about the parent function here of square roots. So on your blank piece of paper, please write the following down. We're going to write down y equals the square root of x, and then we're going to talk about what value should we plug in. Like, I don't want to have to graph decimals, so if I can, I want to be picky about what numbers I choose. Now, we talked about this last unit. This is a risky situation. We use that term, risky situation, that Mr. McFarland used in the videos. What is the smallest value that I can have inside a square root? A 0. So I know x needs to be greater than or equal to 0, and for that reason, I'm going to start with 0. The square root of 0 is 0. The square root of 1 is 1. Now, I could do 2 and I could do 3, but the answers I get, I'll show you if I grab a calculator, they're ugly, irrational numbers. Square root of 2, I don't want to have to graph this irrational number and try to be precise. So what I'm going to do is I'm going to choose perfect squares. Take your paper and flip it over to the front side, please. I'm going to choose numbers like 1, 4, 9, and the reality is I'm not going to continue to choose these numbers because I'm not going to be graphing something where I go out to 16 on the x-axis or 25. So I'm going to go 4 and even maybe 9. 9 may even be too far. Okay, the square root of 4 is 2 and the square root of 9 is 3. And the reality is oftentimes in this small graph, I won't even have to go to this. Maybe occasionally, but oftentimes I won't have to. Okay, so let's go ahead and graph this. We have no horizontal or vertical shifts. There's nothing inside or out. There's no number in front that would cause this shape to be stretched or compressed. This is the basic parent function, 0, 0, 1, 1, 4, 2. And I don't even need to go to 9, 3 because we can see that would be off the graph. Now let's look at number 7. Now in number 7, the very first thing we see is we don't see any number inside or in back. I want to compare this to number 8. This is a horizontal shift. Number 9, horizontal shift and vertical shift. Number 10, horizontal shift and vertical shift. That vertical shift can occur in front or in back. But when there is a number stuck in front of the in front of the square root, like 1/2, 2, 3/2, or 3, that causes this shape to change. So the shape is either going to grow at a faster rate, or it's going to become flatter, or in some cases we're going to see it actually can flip and reflect across the x-axis or even across the y-axis. Let's get started. Let's look right now at number 7. Let's look right now at number 7. Whenever there is a number out front, we're going to multiply that times the y's. 0 times 1/2 is still 0. 1/2 times 1 is 1/2. 1/2 times 2 is 1. So here we go. This is my first point. I'm going to call this the initial point. I go to 0, 0, that's my initial point. Then I go over 1 and up 1/2, and over 4 and up 1. 1, 2, 3, 4, and up 1. We can see it's still the same shape as the first function, but it's been flattened out. That word in math is called compress. If you are ever in charge of your house of bringing out the garbage and you want to be lazy, you compress, you push down the garbage, right? You maybe get another day's worth of trash inside there. You compress it or push it down. That's what we just did with number 7. We compressed it. Let's look right now at number 8, not number 7. Okay. There is no number in back. Please do me a favor and go +0. There is no vertical shift, but there's a horizontal shift. And just like absolute value, with square roots, your horizontal shift is always going to lie to you. So instead of going to the right 3, we're going to go left 3. Now, why am I not going up or down? Because there is no vertical shift. So this is where I am. I'm going to be lazy and write down a very, very quick table, 0, 0, 1, 1, 4, 2. And whenever there's a number stuck in front, we're going to multiply by that number. So 0 times 2 is 2, 2 times 1, is 0, 2 times 1 is 2, 2 times 2 is 4. So this is going to be my point. I choose the point just like I did for absolute value. I choose the point, and that's like my 0, 0. So from this point, I'm going to go right 1 and up 2. Right 1, up 2. Go back to the point. Right 4, up 4. 1, 2, 3, 4, and up 4. And this is still the exact original shape, but what's happened, it's growing at a faster rate. It's growing at a faster rate. It's growing by a factor of 2. We stretched it. It's growing faster. Now, number 9 may seem a little scary too because the number out front is not pretty. It's a decimal, 1.5, or we can think of it as a fraction. We always start by finding this initial point. How do we find this initial point? I'm going to go to the left 2 and down 1. Left 2, down 1. And for some students, it works to cross out the horizontal shift and the vertical shift when you're done. Then I'm going to make my quick table, 0, 0, 1, 1, 4, 2. Because I have a number out front, I need to multiply it. So 0 times 1.5, because 3 halves is the same as 1.5, is still 0. 1 times 1.5 is 1.5. And you can think of this however you want, or if you wanted to leave this as 3 halves, because that makes sense to you, they're equivalent. And now I'm going to take 2 times this, so you don't get a calculator. You're going to take 2 times 1.5. There's a couple ways you can think of that. 1.5 is like $1.50. If you double $1.50, what are you up to? $3. Or other people like working with fractions, so they're going to take 2 times 3 halves. Okay, 2 times 3 is 6, 1 times 2 is 2, and we get the same answer of 3. So these are my 3 y values and corresponding x values. 0, 0 is always this initial point. I'm going to go right 1, and I'm going to go up 1.5. Right 1, up 1.5. Right 4, up 3. Right 4, 1, 2, 3, 4, and up 3. Number 10, when we're looking at it right now, I'm going to shift right now to the right 2. And remember, this vertical shift doesn't always have to be in back. Right 2, up 1. Right 2, and up 1. And since there is a number in front, anything other than 1 in front has to be multiplied by my y's. So this would generally be, oh, I just did the wrong parent function. I'm talking about the World Series, and I got off there. 0, 0, 1, 1, 4, 2. I'm taking 3 times my y values. 3 times 0 is 0. 3 times 1 is 3. And 3 times 2 is 6. This is like my 0, 0. I'm going to go over 1 and up 3. Over 1 and up 3. Then from this point, I'm going to go over 4 and up 6. 1, 2, 3, 4, and up 6. 2, 4, 6. The larger the number out front, we say it's stretched more. It's stretched by a factor of 3. Okay, let's look at number 23. I'm going to go quickly through this. I'm going to shift right now when I look at number 23 to the left 2 and down 3. Left 2 and down 3. Now here's where a lot of students get confused. This is a negative 1 outside. Anything other than a positive 1 gets multiplied by the y's. This becomes 0, negative 1, and negative 2. How does that impact our directions? This is like our point. I'm going to go right 1 and down 1. Right 1, down 1. Right 4, down 2. 1, 2, 3, 4, and down 2. As a reminder, 28 is being cut off, so you flip to the back side. I can see that it was not properly copied. Please write down this equation above or below 28. Again, we always start by finding the translation. So I'm going to move it, translate it, to the left 2 and up 3. Left 2 and up 3. Now, the number that's stuck outside of the square root, in this case, it's not just 2, it's negative 2. It's being multiplied by the y's. 0, negative 2, and negative 4. This is my 0, 0. I'm going to go right 1, down 2. I'm going to go right 4 and down 4. Let's see, 1, 2, 3, and 4.